Number 22, the integral from 2 to infinity, sine x over x squared minus 1 dx. This is improper because the upper limit's infinite. We do have a domain restriction, but our interval, the limits of integration, I should say, don't go into those problematic points. So we're okay. For this guy, we're going to do a comparison test. It's probably the easiest to do that instead of evaluating this interval. It's actually quite hard, if I'm not sure how to do it right off the top of my head. So let's take the advantage of the fact that sine of x is less than or equal to 1. That's just the range of sine x, part of the range. It ranges from -1 to 1, if you remember, okay? So we can write this inequality. Sine x over x squared minus 1 is less than or equal to 1 over x squared minus 1, okay? This right-hand side is much easier to evaluate, okay? We can do partial fraction decomposition, actually. Okay, so I rewrote it as the limit notation first. I did the partial fraction decomposition. I'm not going to go through the steps for that. I don't even show it, but once you do it, you should get -1/2 and half, okay? And then we take the antiderivative. That's right here. We do fundamental theory and calculus and all that business. I'm going to skip through the steps. You can pause the video and check it out. But we get that the limit is, or the improper integral evaluates to half times 1 plus ln 3. This guy converges to this number. And since our guy is even smaller, our guy's for sure going to converge. It's going to converge to something smaller than this, but doesn't matter. It's finite. It's going to converge, okay? So this is one comparison you could do. Obviously, you might not want to do this partial fraction decomposition. So if you can find another function that's easier, even better. I just showed what I would think of right away. And this partial fraction decomposition is not too bad. You could, for example, set up this inequality that our function is less than or equal to 1 over x squared. But it's kind of hard to show this without graphing it. So if you're not allowed to graph in calculator or anything like that, it's kind of hard to show this. So if your teacher makes you actually prove this per se, I didn't really prove this because this is kind of, well, I guess I kind of did right over here, but this is harder to show. So if you have to prove it, if you're able to, great. It's much easier after you do the comparison test. If not, then you should choose a different function. Okay.